Hi everyone, welcome back. In this module, we are going to discuss about Python identifiers, reserved words, and intro to our data types, right? So let's get started with this tutorial. So guys, the very first thing is what is identifiers? You can you can think like any name in the Python, any names, right, are called identifiers. Any name. And everything in Python is object, right? So either it's a name of variable, class, method, everything, whatever you define is called identifiers, correct? Okay. So the next uh, thought is the rules behind creating the identifiers. How it's basically a naming convention, right? How we can name a variable or name a class or name any method. There is certain rules that is applicable and we have to follow in order to make the Python syntax correctly, right? So let's go with the first rule. Here is the first rule. It's saying like any combination of capital E to capital Z, small a to small z, numeric 0 to 9, and only one special character that is underscore. So let's have a quick test here. So I'm going to define a variable just uh, like test uh, test equal. This is how we need to assign values in the variable, right? So for example, I have assigned 20, right, in the test variable. So I'm going to assign another values in tvar, just like tvar 0000, and we type value 20. Again, no errors. Now I'm thinking to instead of a, I'm gonna use at the rate and then assigning a value 20. See, this time it's going to throw the syntax error. Basically, uh, it's very difficult to assign the expression here, I mean the value into this expression, because this is not a standard identifier, right? It's not following the naming convention here. So that is important thing we have to follow the standard rules. There are five. This is the first. Let's go with the second. We need to start from alphabets and underscore. So let's give another test for this. So the another test for rule 2. I'm just writing the rule as well in the comment, right? So that it will going to make sense. So rule 2 is it should start from either underscore or the, just like if I start with underscore variable 1 is equal to, let's suppose hello, right? It's perfect, no errors. If I start with variable 2, assign the same value like hello, it's still perfect, no errors. Now I'm creating third variable like this and assigning the same value, not hello, it's hello, right? Now you can see the errors. So I hope this rule is clear. Instead of a small thing, you can use the capital var as well. No issues in that. Just like variable 4, and here we can pass any values. So it's going to accept. So the idea here is we need to start from either from underscore or any alphabets, not from the numeric. Correct? Second rule are clear. Let's go with the third rule. Python is case sensitive language. So case sensitive means it's going to treat, for example, let me create here rule 3. Uh, rule 3. So I'm going to create two variable here with the same name, just case will be different. For example, uh, var 5, var underscore 5, variable 5 equal some value, let's suppose 20, and I'm creating var in caps, and with I'm also removing 5 here, only var, and in the capital var here I'm assigning 70, right? So after running this, if I print the value of a small var, you can see it's 20, and if I print value of capital var, you can still see 70. So it's going to treat capital and a small differently, right? It's not same for Python as per the syntax. So be mindful while using the any alphabet in caps or in a smalls. Use it in the same way later on. Let's move with the fourth rule, uh, that is related to something no character limits. So we can quickly test this rule, but it's just a like from a good habit perspective, we can define a meaningful small length identifier that will going to help us in rewriting the program or repetition. But for now, if I, for the trial purpose, let's suppose if I just type the variable like this, something length can be anything, right? So, and I am going to assign value something, it's a long identifier, right? And then I'm not sure what I type, but we can call whatever identifier we have assigned with the same name. So I'm going to copy it, and after running, see, you can see the values is assigned. So if I call this, run this, so you can see the values. So there is no character limit, but this is not going to make any sense what values will be inside. So it's always a good habit to create meaningful a small length identifier, right? Agree with me? Let's move with the last rule of creating identifier. And as per the last rule, we are not allowed to use the reserved words. The reason is that reserved words has their specific functionality, so that we cannot use that. So let's go and check it. For example, there is certain reserved words. I'm just using one called if. So I'm using if equal to, let's suppose any value we can take, for example 5. If I run it, there is a syntax error, and we get it from because if is a reserved word. I have a list of all the reserved words in Python. In the here you can see, like, idea is not to understand everything. We will discuss each and every word in very detail. It's 33 in count, and each and every word has its meaning, right? And we are going to learn each and everything in separate module, one by one. So that's not a bigger challenge. Let's move with the next topic, and that is our data types. So basically, type of some values. For example, you can see the type of 5. It's going to say, hey, it's integer type. The type of hello. See, it's str type, right? The type of, if you say some other values, for example, 1 comma 3, something like that. So it's showing its list type. If we are going to type another value just like 1, so we are going to discuss one by one, and in forthcoming lessons as well if required. There are many types. So the idea here is just to have a fair understanding. Each data type has certain limitations, certain features. So we will get into that. And for now, let's start with integer. Basically, integers are any numeric values, right? Example, if I define I variable, I vary is kind of, you can think it's integer variable. So as per the naming convention, whatever we write, it's something should be relatable so that it's going to benefit later on. We need not to worry about which kind of variable it is. It's kind of good practice, right? You can define any name as per your wish, based on the identifier rules. We have to follow it, right? So let's create a value with the value of, let's suppose, 299. Now I'm going to print the type of eyewear. Can you guess what will be the output? Here you can see the type of eyewear is integer, correct? So see, for example, if we have integer values, for, let's suppose, I'm making it very generic. For example, a equal to 5, and I'm just having another values with 9. So I can do certain operations on it. For example, if I try to add it, just like a plus b, you can see the output is 14, right? So the idea here is once we know the types, then we can easily able to predict what uh, how we can perform certain operations, and we can predict like either our code is following certain syntax rules or not. Creating a C variable with some string value, right? Here I'm typing hi, and you can think of like if I do a plus C here, so it's going to uh, it's throwing the type error, showing that unsupported operand type for concatenations. It's kind of plus is going to perform both the operations. With integer value, it's going to perform the addition, and with a string value, it's going to concatenate with the string. So let's test this rule with another a string variable. Here I'm writing a name, for example, Subham, right? So if I do C uh, plus D here, so you can see it's showing hi Subham, right? And if you need certain more spaces, you can just give a space here and then concatenate with plus. So see, now it's saying hi space Subham. So the idea here is we can use the plus sign with both of the integer part or both of the string part, not a combination of that. Here a combination of integer and string, so it's going to throw the error. So that's why it's very good habit to get to know the types of variable. So we are going to discuss in detail here as well. So I believe like you have a fair idea of integer values. It can be of any length. For example, I'm creating a value long int variable, and I'm going to assign in a figure length value. You can see, you can think of the length, and you can guess the numbers here. I have created, and let me print this. So it's going to reprint the number for us. So there is another function in Python just to calculate the length. So I'm going to type our variable in length function. I know it's going to produce an error. The reason is it's not going to calculate the integer digit. It's only for a string and the uh, list and all the like which has some length. So integer has no length. So there is typecasting in it. Don't watch it. Don't think about it. We'll going to discuss it in later sessions as well. So for now I'm just converting it our integer numbers in a string, right? And whatever this is the long integer variable, and the idea here is to check their type. So the type or the length here is, and at the end you can see now it's going to show the length of the variable, like it's 158, meaning that we have assigned 158 numbers digits in it, right? So 158 digits, it's so huge number, and our variable is going to store it without any issues, right? So let's go with the next topic, and that is the float data type. Think of it as any decimal values, right? So float is going to be a decimal values. Let me mark down it, and then here uh, tu- 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 tu, float data type. I'm going to use f variable is equal to 2.3456, something like that. And you can see the type of f variable. So it's going to say it's a float variable. So, or alternatively, if you can use like something uh, result is equal to 10 divided by 3. So it's also going to be float uh, values. So if I also do the type of 10 divided by 3, so it's going to be a float. Also, instead of the values, I can use the result variable in it. So you can see the type of the result is going to be float, right? So it only contain the floating or decimal values. Uh, even we can represent the floating numbers in exponential form as well. For example, if I define f is equal to 1.2 e to the power something like, let's suppose, 5, so it's going to accept without any error. So the idea here is it should be in the decimal, and later if we're going to print the f variable, so it's going to uh, print in the decimal form, right? So exponential for you can take it as a input, but it will going to print as a normal decimal form, right? The next is our Boolean data type. So let me type for it. Uh, Bool data type. Okay. So Boolean has two values, right? One is true and the other is uh, false. Okay. So later we are going to use it for many checking the many conditions and so basically it's going to represent as 0 and 1 internally in Python. So the true values means 1 and the false means 0. So how we can get to know so there is uh, a way to check it. For example, I'm going to utilize the print function, and inside the print I'm going to do true plus false. Can you guess the output? Guys, yeah, it's 1. The reason is that true equal 1 and false equal 0. So now you are able to think. Still, you can say it could be anything, but let me print the value of true only. Uh, okay, mm, true plus 0. So now you have idea like I have added 0, so whatever the value of true is going to print out. Okay, correct. If I also do uh, let's print true minus false. Can you think for the output? It's still 1, right? Even though we can multiply it just like true multiply by true, right? Perfect, it's 1. Boolean is going to represent a binary numbers, right? 0 and 1. Okay, so still clear, right? We need not to use print every time in this kind of IDs. It's by default. Okay. Uh, let's move with our another data type that is the most important data type here. It's str data type, right? S str data type. It's string. Um, see, there is many ways to write string values. So for now, I'm going to use uh, each and everything. For example, see, str variable 1 is equal to, for example, let me use s variable 1 is equal to, we can use single quotes, hi, it's going to accept, right? Let me use the s variable 2, and here I'm using double quotes, hi. It's still going to accept. Let me define another variable. Let's see v3 or s3. Let me take s3, right? And this time I'm going to use triple time single quotes. And here I have defined hello. Still perfect, no issues. Still, let me check the type here. Type of s3. It's a str type. Python has no issues. It's accepted, right, without any issues. Okay. What about something like that? It's also perfect, right? So we can think of like four ways we can, yeah, four ways we can uh, utilize our. So instead of four, we can call it as a triple, right? Three ways, like either we can use single or double or triple, something like that. Okay. S- So mainly we can use the triple quotes to define multi-line string. For example, here there is a limitation. If I use s variable high and in the next line if I enter hello, it's going to throw the syntax error. But if I do the same thing with S3 and here I'm going to write hello world and it's successfully accepted. And if I print it uh, S3, you can see the output. So now you have a fair idea when which kind of string we can refer. For example, if we have to write a string values in one line, then we can refer either single or double. But if we have multi-line string coming, then we have to use this multi-line string. I mean triple quotes. Okay. Usually we use this triple quotes to define some doc strings, right? And for the comment purpose. Uh, let's perform some operations on the string. Usually string has many operations as we perform some operations on Boolean data types. We did some addition, subtraction. We also performed some operation on float data type. We also did something on integer. Here, if you see, we did some addition and all. So let's perform some operations here with some string values. So let me take like inside the memory, it's going to assigned with certain indexes, right? Starting from 0 till -1. And Python has double indexing capabilities. If I, for testing purpose, if I do s of 0, so it's going to pull out from the entire range, it's going to pull out the first element, right? So check it. So at the end, this is the ninth values. As Python has capability to uh, do a positive as well as negative indexing, right? So for the negative indexing, the last element is assigned as -1 index. So if I do s of -1, it's going to populate the last element. So instead of counting, we can assign some. I'm just going to slice the string, whatever required, I'm going to slicing it. So you can think like on what particular index we need to slice it. So here it's 5 and then till the last. So if we are able to give the starting point of S5, it's going to populate. Okay, this is the fifth index from where it's going to cut it, but we need it from the sixth. Okay, so that we will get our user. So now, if you can see, it's sixth index is U. So now we need a range till the end. So there is two way. First way is that we know the starting point till the ending point. So here it's very difficult to say the ending point. The reason is that it's going to populate one lesser than the endpoint. The syntax here is any string values, right? We can use the square bracket. We can give the starting index, then use the semicolon, give the end index, but end index is going to be end -1. Here we can define it as a step. Okay. So let me write another thing. For example, I'm just defining a, str1, and here I'm assigning a b c d e. Okay. Utilize all the steps. I'm starting from 0 till the fifth, and a step going to give 1. Okay. So here I have mentioned 5. That's why it's able to produce uh, A, B, C, D, and E. The reason is that the indexing of A is 0, for B is 1, for C is 2, for D is 3, and for E is 4. To test it, if I type str1 and if I produce the fifth string, it's going to throw an error saying that string is out of the range because there is no fifth index existing in our uh, string item, right? There is no fifth index is as per the value. So the max index that is available in our string 1 is 4. So str1 of fourth index. So you can see the value of fourth index is E, the last value. Here we are able to execute this loop. The reason is that it's not going to check the end string. Instead of 5, if I type 10, still it's going to populate the end of the string. It's not referring till the end, right? So here it's kind of exception in the uh, from the end perspective. You can give higher, it's going to ignore from the top of the list, right? Instead of 10, even we can ignore that and we can use it. So still it's going to populate the entire range. Okay. To reverse the string, we can use -1 entire string. It's going to reverse the entire string. To get into the to populate everything, let's suppose if I have long string, long str equal to I have used some uh, big string value just like this. Okay, so I'm instead of counting, if we want everything to be sliced out, so we can use longest str, and instead of slicing we can give us single colon. It's going to uh, retrieve the entire values and paste it here in uh, in a variable, right? Var underscore 1. So I know 1 to 3 is the numeric number, and still if I want to use var 1 and I did some addition with let's suppose var 1 again, right? So sorry, it's underscore, no? Hmm. So you can see instead of adding it, it's going to concatenate 1 to 3 1 to 3 as just it's kind of a string variable. That's why. So if I know that like it's by mistake it's inside the string values and it's integer values only, by mistake it's converted into the string. So to overcome or to changing its data type, Python has flexibility to change the data type, and here you can use int of var underscore 1, and now you can see the values is in integer format. How we can justify? We can use the type command so that it will going to tell the type. So now you can see it's integer type, and just to verify I'm still going to use the original form of var1, right? So it's going to show that it's still in string type, but after doing it it's going to convert into the integer for the time being and not in the original variable. Original values and variable will be same only, there is no change in the original data type. For the time being it's converted into integer, and until and unless we are not going to update it, it will be in string format only. Okay. If I convert it and then if I repeat the process, for example if I print integer of variable 1 and then if I did the addition of integer of variable 1, so now you can say it's 1 2 3, it's kind of sum up with 2 4 6. There is no concatenation, it's sums correctly. I have lot more to discuss in upcoming sessions. So just to recap what we have covered, We have covered the identifiers, we have covered the reserved words, what all are, and also we discussed the rule of uh, defining and creating the identifiers. Along with that, we discuss some data types, important data types, just like integer, float, uh, boolean, a string. There are many more data types as well. We're going to discuss it in upcoming sessions. Thank you so much for joining this session, and we'll surely going to deep dive into each and every concept later on. Till then, keep watching this video. Stay safe. Happy learning. Please do like and share and subscribe to this channel. Thank you.